Why do we draw the sun yellow when it's actually white? No, seriously, go outside on a clear day and try to look at the sun. Don't stare directly at it, of course, but glance at it briefly or observe the light bouncing off a white surface. It's not golden, it's not orange, it's a brilliant, almost blinding white. So where does this yellow myth come from? Why do crayons, emojis, and even weather icons depict the sun as a warm yellow circle? Here's the strange twist. The sun looks yellow to us, but not because it is yellow. In fact, from space, with no atmosphere in the way, the sun shines pure white. That's right, the same color as fresh snow under noon light. So the question isn't just, what color is the sun? It's, why do we see it as something it's not? This isn't just a curiosity. To answer this, we'll need to unpack how light behaves, how our eyes and brain interpret that light, and what Earth's atmosphere secretly does every time we look up. And once we're done, you'll never look at sunlight or shadows the same way again. Ready? Let's crack open one of the biggest optical illusions in your everyday life. Let's start with the sun itself. What kind of light does it actually emit? Surprisingly, it's not yellow or orange or red. It's all of them at once. The sun produces what scientists call white light, which is a blend of all visible wavelengths. Imagine a perfectly balanced smoothie made from every color of the rainbow. That's sunlight. When you pass it through a prism, like Newton famously did, it breaks into the familiar spectrum: red, orange, yellow, green, blue, indigo, violet. These colors aren't added by the prism. They were always there, hidden in the white. So far, so good. But here comes the twist. If the sun emits white light, why doesn't it look white when we glance at it in the sky? Why do kids draw it yellow? Why do we call it a golden sunset? The answer lies in the invisible filter wrapped around our planet, Earth's atmosphere. Think of the atmosphere like a giant pair of sunglasses, except instead of blocking light evenly, it messes with different colors in different ways. This happens because of a phenomenon called Rayleigh scattering. And to understand that, we need a simple, vivid analogy. Imagine you're in a swimming pool filled with beach balls of all sizes. The smaller balls, let's say blue ones, bounce around a lot more when you try to walk through them. The bigger red balls, they're harder to push around. Light behaves the same way when it travels through air. The shorter wavelengths, like blue and violet, get scattered by the tiny molecules in the atmosphere much more than the longer wavelengths like red and yellow. That's why the sky is blue during the day. You're literally seeing scattered blue light, bounced around in every direction. But here's where things get really interesting. The more atmosphere sunlight has to pass through, the more blue gets scattered away. That's why at sunrise or sunset, the sun looks red or orange. The blue light is filtered out, leaving behind the warmer tones. At noon, when the sun is high overhead and light travels the shortest path through the atmosphere, there's less scattering overall. And if you could look directly at the sun, you'd see it's actually dazzlingly white. So why do we still think of it as yellow? That answer comes from a trick played by our own eyes and brain. And we'll get to that next. Let's talk about your eyes. Because even if the sun sends us white light, and even if the atmosphere shifts some of that light around, there's still one final step in the illusion: your brain's interpretation of what it sees. Our eyes aren't passive cameras. They're highly optimized, constantly adjusting biological machines. And one of their main tricks is something called color constancy. It's like your brain saying, "Don't worry, I've seen this color before. I'll correct it for you." Here's an analogy. Imagine you're looking at a white shirt under a red lamp. The shirt looks red, but you know it's white, right? Your brain helps you correct the color based on context. Now flip that. When you look at the sun high in the sky, there's very little around it to provide color context. It's surrounded by the blue sky, which your brain sees as cool-toned. So in contrast, the sun appears slightly warmer, more yellow, even though it's still emitting white light. It's a subtle optical illusion, like when you see a gray square on a blue background and swear it's orange. But there's more. Our eyes also have 3 types of color receptors: cones sensitive to red, green, and blue, and they're not equally distributed. Most of us are more sensitive to the green-yellow part of the spectrum, so when all the wavelengths of sunlight hit your eyes, that part gets a tiny boost. It's not a huge difference, but it's enough to nudge your perception slightly toward yellow. And since we're not usually staring at the sun directly, again, don't do that. We mostly perceive it through its effect on the world around us. On clouds, on sand, on your skin, And those things reflect sunlight in ways that subtly reinforce the idea of warm yellow light, even though the original source is white. Over time, that impression becomes so strong that we encode it in our culture. We draw the sun yellow, we call it golden, we paint it that way, model it that way, even feel it that way. But that's just how our brains color in the experience. The actual physics tells a different story. And it gets even weirder when we zoom out and ask, is the sun white to everyone, everywhere in the universe? Turns out, not quite. Let's go cosmic. Imagine you're an alien floating somewhere far from Earth, maybe on the dark side of the moon or even in deep interstellar space. You look at our sun, no atmosphere, no scattering, no blue sky. What do you see? A white star, crisp, balanced, intense. The sun is classified as a G-type main sequence star, and by cosmic standards, it's actually quite average in temperature and color. It's not a red giant or a blue supergiant. It sits neatly in the middle, shining with what astronomers call white light. In fact, when we study stars scientifically, we don't assign them cartoon colors. We use instruments called spectrometers, which break light into its component wavelengths and let us see the real story. And when we do that with the sun, we get a broad, smooth curve peaking in the visible range, especially around green. Wait, green? Does that mean the sun is green? Not exactly. That's where our human perception kicks in again. Because our eyes combine the full spectrum of light into a single experience, and that experience, when balanced across the visible range, feels white. If you isolate just the peak of the sun's emission, it leans slightly toward green, but that doesn't mean the sun is green any more than it's purple just because violet light is present. It's like listening to an orchestra and trying to decide what one instrument defines the whole sound. You can't. It's the mix that matters. So here's the big idea. When seen from space, the sun is unquestionably white, pure, energetic, evenly blended. But on Earth, we view it through two powerful filters, the atmosphere and the human brain. One distorts the light physically, the other interprets it psychologically. Together, they create the illusion of a yellow sun. And because we've grown up with that illusion, we've built an entire symbolic language around it. From children's books to weather reports to mythology, the golden sun is everywhere. But scientifically, that warm yellow glow is just the echo of Earth's air and our own biology playing tricks on us. So if you ever travel beyond the atmosphere, even just to low Earth orbit, and you look at the sun, filtered through the right protection, of course, you won't see a golden disk. You'll see something cleaner, sharper, more dazzling. You'll see the sun as it actually is, and it might just change how you think about everything lit by it. So here's the big picture. The sun isn't yellow. It never was. It shines with white light, a perfect blend of every color in the visible spectrum. But by the time that light reaches your eyes, it's been scattered by the atmosphere, filtered by your biology, and reinterpreted by your brain. And together, those layers create a beautiful illusion, one so strong we drew it in every childhood picture and built entire myths around its golden glow. But now you know the truth. The sun is white, and that changes everything. It reframes how we think about daylight, color, and even perception itself. It reminds us that what we see isn't always what is, and that science gives us a way to peel back those layers and see the universe more clearly. Every time you step outside on a bright day and feel the warmth on your skin, you're being touched by a white star 150 million kilometers away. That's not just poetic, it's real. And the next time someone says the sun is yellow, you'll know something they don't. You'll know that the color of the sun isn't a property of the sun. It's a story told by the earth and your mind. And if you loved learning that, imagine how many other invisible truths are hiding in plain sight. This is what we do here at How It Actually Works. We decode the everyday magic around you and give you the keys to understand how the world really works. So if this made you see the sky in a new light, hit like, share it with a curious friend, and subscribe for more. Because curiosity isn't just a feeling, it's a superpower.